Have you ever stared at a candle flame and wondered what's really going on in there? It looks calm, almost magical, but inside it's like a tiny lab, full of fire, physics, and chemistry, working at the atomic level. Today, let's break down a candle flame step by step. The wax, the gases, the colors, and the science that makes it all glow. Wax and wick. A candle starts with something simple, wax. Wax is made of hydrocarbons, chains of carbon, and hydrogen atoms. When you light the wick, the heat melts the wax near it. The liquid wax climbs up the wick like water moving through a straw. This is called capillary action. At the top, the heat burns liquid wax into vapor, invisible fuel gases. And here's the first surprise: the flame doesn't burn solid wax or liquid wax, it only burns the vapor. Zone 1, the wick zone. Right above the wick, wax vapors gets so hot that chemical bonds break apart. Carbon, carbon bonds, carbon, hydrogen bonds all snap into smaller pieces called radicals. Radicals are like tiny, restless atoms and molecules. They are super reactive and they drive the flame forward. Zone 2, the blue zone. Now, oxygen from the air enters the flame from the sides. It collides with those radicals. Hydrogen reacts first, forming water vapor. Carbon starts turning into carbon monoxide and carbon dioxide. These chemical reactions release energy. Here is how it works. When atoms form new bonds, like hydrogen bonding with oxygen to make water, they move into a more stable state. This extra stability energy is released in two ways: heat and light. Most of the energy becomes heat. Think of it like water stored behind a dam. The water has potential energy while it's held back. When the dam opens, the water rushes out, releasing energy as motion. In the flame, the energy from breaking and forming chemical bonds makes the molecules move faster, and we feel this as heat. That's why the base of the flame is so hot. Some energy excites atoms and molecules. When these excited molecules drop back to their normal state, they release tiny packets of energy called photons. That's the blue light you see. Most of this light comes from CH and Ca2 fragments glowing in the flame. This zone reaches around 800 degrees Celsius. Zone 3, the bright yellow zone. Next comes the most eye-catching part, the glowing yellow middle. Here, oxygen is limited. The carbon fragments stick together, forming tiny soot particles. As they rise and heat up, these particles glow like hot coals. That's the bright yellow color you see. It's not sparks, it's thermal radiation, just like a light bulb filament glowing with heat. Zone 4, the outer edge. Finally, at the very edge of the flame, oxygen is plenty. Here, the last bits of fuel and soot burns completely into carbon dioxide and water. This is the hottest zone, reaching around 1400 degrees Celsius. Sometimes you will notice a faint blue edge that comes from OH radicals giving off light. Most of it is ultraviolet, so our eyes can't see it. The flame's limit. And why does the flame spread endlessly? Because outside its edge there is no fuel vapor. Oxygen alone can't burn, it needs fuel. When the fuel stops, the flame goes out. So, the next time you look at a candle, remember that calm little flame is a roaring dance of atoms, breaking, reacting, and glowing. A tiny universe of fire right in front of your eyes.